the 2021 Fall AMC 10A. So we are asked the maximum number of balls of clay of radius 2 that can completely fit inside a cube of side length 6, assuming the balls can be reshaped but not compressed before they are packed in the cube. So we are clearly being asked about volume because of their 3D nature. So we'll first find the volume of the clay ball, and we'll call that V sub B. And we must recall the volume of a sphere, which is 4/3 pi r cubed. We plug this in here, and we get 4/3 pi 2 cubed, which is 32 over 3 pi. And next we are asked what the volume, we want to find what the volume of a cube is with side length 6. And the volume of the cube is just length times side times, side times width times height. And that is just 6 cubed, which is 216. Now we want to see how many balls can be reshaped but not compressed before they are packed in the cube. So let's do 216 divided by 32 over 3 pi to basically just find the exact number, which would be packed inside the cube. But keep in mind that we want to find the greatest integer less than or equal to that number that we get here, because we can't have partial amount of balls, of course. So we just solve this. 216 times 3 over 32 pi. 216 times 3, 648 over 3 pi, which is, hold on, did I do something wrong here? Okay, 10, 18, but that's 32, which would be 2. So we'll divide by 4 and we get 162 over 8, which is 81 over 4 pi, and that's all you can simplify. So it's 20.25 pi, or 81 over 4. And now that we know that the floor function, the floor function of VC over VB, right, is 81 over 4 pi, or the floor function of this. We do the floor function to find the greatest integer less than or equal to. So I'll just write this out here actually. The floor function of x is equal to the greatest integer, right, less than or equal to x. So like, for example, so let's say that we have like 10.6. This would just be 10, right? Because the greatest integer less than or equal to x. So that would also mean 10 is equal to x by that rule, right? Okay, so now that we know that 81 over 4 pi balls can be packed, we must find the integer number that can be packed. So we can approximate with pi is about 3.14, and plug this in here. So 4 times 3.14 is 12.56. So we know 12 is less than 4 pi, which is less than 13, and we can translate this into fractions to compare that with 81 over 4 pi. So just like this. And we're just doing this because we know these values, these 81s can just base. And so what is the floor function of 81 over 13, right? So if we do this math, we can see that we know that 13 times 6 would probably give us the closest, which was 3. So we get 6R3, but with floor functions, that's just 6. So 6 is less than or equal to 81 over 4 pi, which is less than or equal to, and 12 divided by 81, we'll probably want to get 6, but let's just check. 72, 9, so 6 with the remainder of 9, but just, we take the 6. And this means that 81 over 4 pi is equal to 6, right? Because if we have this, then the floor function must be between 6 and must be like 6.00000, etc. on 1, or must be less than 6.99999, like that. So we know it must be 6, which is D, or final answer.